In this video, we're going to go over the intermediate value theorem and then look at an example of how we would use the intermediate value theorem. So first, let's write out what is the intermediate value theorem. Suppose f of x is continuous on an interval from a to b, and that's the closed interval from a to b, and y sub naught is a number between f of a and f of b, comma. Then there exists at least one number c between a and b such that f of c equals y sub naught. So that might not be very clear, but one thing that helps us understand this theorem is a little diagram. So here's our little figure that goes with this theorem. And once we talk about it, it actually makes a lot of sense. Alright, so we have some function that's f of x on an interval from a to b. So we'll say this is a and this is b. And y sub naught is a number between f of a and f of b. So let's say up here is f of a, and down here is f of b, and then right here is our y sub naught. Then there exists at least one number c between a and b such that whatever this c is, we put into function, it equals y sub naught. So if I were to hypothetically sketch some function in here, like so, then there has to be some c between a and b such that this f of c equals y sub naught. And in this case, there are 3 points where that exists. So this is what we would call an existence theorem. And let me do another, so this is the diagram you want with your notes, but let me do another quick just idea about what's happening here. Yeah, I'll draw this down here. So let's say I have some function. Here's a, and this is f of a. And then here is b, and down here is f of b. So if we ask a little bit of an easier question, if I say that we have some function, and we know it starts here and it ends here, and it is continuous, does that function go through the x-axis? And the answer is yes. In order to get from here down to here, at some point, it has to cross the x-axis. And so therefore, that is what the intermediate value theorem says. And then it just says it exists. We don't know, maybe we might not know exactly where it exists unless we have a function, and we don't know exactly how many times it goes through the x-axis, but it does happen. Now, in this version here, we just say that we have some y sub naught, And then we have a point up here, a and f of a, and we have a point down here, b and f of b. And again, the question was, well, if you start here and you end here, at some point do you go through this imaginary dotted line, y sub naught? And the answer is yes. Of course, the key to this is that it's continuous. If it's not continuous, let's give an example. Let's say it was not continuous. If it was not continuous, we could come here and then just jump down to here, and it wouldn't happen. So the fact that it is continuous is kind of key. Let's do an example. Does the function f of x equal x cubed minus x minus 1 have a 0 in, does the function have a 0 in the interval from 1 to 2? Okay, so we have this function x cubed minus x minus 1, and we don't know what this looks like, but we could imagine that along the x-axis, here's 0, here's 1, here's 2, that somewhere along the x-axis it crosses the x-axis. And this question's asking, does that happen between 1 and 2? Of course, if we wanted to, we could say, well, what's x cubed minus x minus 1, set it equal to 0 and solve it. And if we solve that, then we would figure out all the points where it crosses across the x-axis or equals 0. But in this case, this is not something we would be able to solve, so that's not practical for this problem. So to help us figure this out, we're going to use the intermediate value theorem. And this one's not so bad because it gives us an a and b, so we just put in f of a and f of b. So f of a is 1 cubed minus 1 minus 1, which is a negative 1. F of 2, is, so this should be a 2. F of 2 equals 2 cubed minus 2 minus 1, which is what? 8 minus 3, which is 5. Alright, well, because when we put in 1, we get negative 1, and when we put 2, we get 5. We also notice that this is continuous. All polynomials are continuous. So we have a continuous function. At a, f of a is negative 1. At b, f of b is 5. That means by the intermediate value theorem, it must cross the x-axis. So let's write that out. You can't just say, yes, it crosses the x-axis. You have to explain yourself. So what I wrote was f of x is a continuous function and y sub naught equals 0 is a value between f of 1 equals negative 1 and f of 2 equals 5. Okay, so in the first part of this sentence we said that, or this explanation, we said that it's a continuous function, which is key for the intermediate value theorem. We said that this y sub naught equals 0, so that means that's the value we're looking for. And it is in between 1 and negative 1 and 2 and 5. Thus, according to the intermediate value theorem, there must be at least one value of x that satisfies the equation x cubed minus x minus 1 equals 0. Therefore, f of x equals x cubed minus x minus 1 must have at least 1, 0. Alright, so there is what I wrote to describe why the function does have a 0. You know, the wording of it can be a little different. The key concepts are you do have a continuous function. You have some value, some y value that you're trying to show that it's going through. And then you do have to indicate that the points go from either below that value to above that value, like so, or vice versa. You gotta state the intermediate value theorem. That's what the theorem we're using. And then the rest of this, you know, it's just wording to say, yes, we do meet it. So make sure when you come to this problem on the homework, or if you come to a problem like this on the test, that you do have some good wording for this, that you just don't say, yes, it does because of some things I did up here. You do have to kind of explain that.